Our next topic is rationalizing fractions. So this is going to be happening to you quite a bit in this unit, as in you'll be asked to rationalize fractions and recognize when something is irrational and that you should always be doing something about it, that is rationalizing. So first, reminders. Rational numbers. Fractions have a numerator, top or dividend, what we are dividing, and a denominator, bottom or divisor, what we are dividing by. The result of dividing the two numbers in a fraction is the value of the fraction. So if I mention the value of a fraction, I'm talking about what the result is, or the quotient. Rational numbers are numbers that can be written as a ratio. So if you think about 1/2, it's a rational number. So there are certain numbers that cannot be. Irrational numbers are things like pi, which goes on non-terminating, e, something you'll learn about a bit later, but it's like pi, it just goes on forever. It's like 2.718, just keeps going. The square root of 2, let's finish that off, the square root of 2, and the square root of 5. The reason being, these are not perfect squares, so you get this decimal that's non-terminating and non-repeating. Okay? When we write fractions, we always, by convention, that is, whenever you're doing this, you want to make sure you write them such that the denominator is always a rational number. It's okay to have the numerator being irrational, that'd be fine. So the square root of 2 over 2, that would be okay. 2 over the square root of 2, that would not be okay. And last, if we multiply the numerator and denominator by the same number, then we do not change the value of the fraction. This is the same way that we got common denominators when we added and subtract fractions some time ago. Okay, how to rationalize fractions. First, let's give it a context. Let's say that you have a 30, 60, 90 right triangle, right? And they tell you that this numerator, no, let's do this. They tell you that the side opposite to the 60-degree angle is 5. Great, you say. Well, we know from the previous video that that means we're going to have to divide by the square root of 3, which means this is 5 over the square root of 3. Here's the problem. 5 over the square root of 3 is irrational, so what do? We change it by multiplying the top and bottom by the same thing. In particular, whatever the irrational part is. So in this case, the square root of 3. The reason being, the square root of 3 times the square root of 3 is equal to the square root of 9, which is just 3. Another way to look at that, it's the square root of 3 squared, which cancels, so we get 3. As a matter of fact, if you take the square root of x, that is the square root of some number, and multiply it by itself, you're always going to get that number. Meaning, you'll get 3 in the denominator. But in order to make this an equivalent fraction, not change the value, right, you need to multiply the top and the bottom by the same thing. So this means that this would be written as 5 square root 3 over 3. And then if you wanted to find this, of course, you'd multiply by 2. Don't forget 2 is the same as 2 over 1. So you take the top times the top, bottom times the bottom, and you get 10 times the square root of 3 over 3. Okay? Let's do a couple more examples. So let's say you had a 45, 45, 90 right triangle, or an isosceles right triangle, like this, right? And let's say you knew that this side here was 8. Well, you know you have to divide by the square root of 2, right? So this would be 8 divided by the square root of 2, which means you then must rationalize it because you have the square root of 2 in the bottom. So you multiply by the square root of 2 over the square root of 2. So you get 8 square root 2 over 2. This can be further simplified. This is the same as 4 square root 2. Reason being 8 divided by 2, because you can reduce things, reduce fractions still, that's okay. All right, some more general examples. Let's say you had some sort of, I don't know, square root of 3 over, well, let's not go with square root of 3 over, let's go with 8 over 3 square root 3, and you wanted to rationalize this because right now you have the square root of 3 in the bottom. You only need to multiply by the square root portion. Remember, the 3 is not irrational, so you don't need to fool with it. What it does mean, though, is you're going to get 3 times 3 on the bottom and 8 square root of 3 on the top, right? So that would be 8 square root 3 over 9. Okay? That's really all there is to it. So if you ended up with, say, 1 over the square root of 2, you'd have to change that change that by multiplying by the square root of 2 over the square root of 2. So that'd be the square root of 2 over square root of 2 times square root of 2 is 2. You can stop once you've gotten just a regular rational number in the denominator, unless you can divide these out, in which case, yes, please simplify it. But that's all there is to rationalizing fractions.